Welcome to another math video. Today I'm explaining the strange organization of our Math 20 topics. It's actually story time. Back long ago, when I was an undergraduate in the time of the dinosaurs, some researchers studied how freshman physics majors, just starting their college career, would sort physics problems from the Intro to Physics class. And the students, unsurprisingly, sorted them by the appearance of the physical apparatus. This is something sliding down an inclined plane. This is a spring. This is a pendulum. This is a string vibrating or a wave going through a liquid. When the same researchers asked the seniors, who were starting their fourth year and had years of experience dealing with intro physics material, how to sort the same problems, the seniors sorted them by which physics concepts and tools and equations were the right way to approach solving those problems. This is a conservation of energy problem. This is a conservation of momentum problem. This is where you should draw a force diagram and see how the vectors go, and so on. Part of becoming a physicist is learning how to get past what is immediately visually apparent, this is a spring, boing, into what tools do you need in this situation. Math is often done much the same, but in a more confusing way. We tend to sort things for a math class at the Math 20 level with fractions and percents and measurement, geometry, ratios, topics like that. Just like an inclined plane or a spring or a pendulum, that's what the problem looks like. But it's a worse issue because it's slightly abstract. So students are often confused and think that this is somehow what the problem is, or how it behaves. But it's not. It's only what the problem looks like. And it is still true, just like with those physics students, that what really matters is which tools you take out of your toolbox to apply to this situation. It doesn't matter what the math problem looks like. It matters what you do with it. So, unfortunately, textbooks still follow a traditional and not as helpful paradigm. They will go through everything: fractions, percents, ratios, rates, measurements, geometry, sorted by what it looks like. But we're going to do something better. This is a proven way to have it make more sense. We're going to start by talking about what I nickname shapeshifting. Shapeshifting is everything you do that changes just one number. We'll look at how to round numbers, what fractions really are, how to move back and forth between fractions and decimals. When some fractions are ratios or rates, what does that really mean? What percents are, how to move back and forth between percents and decimals and fractions. Some history of measurement units and how to convert between measurement units that are close together, like feet and miles. We'll talk about SI prefixes, what you might call metric system, and we'll talk about exponents and square roots. You won't get confused about what tools to use in a situation because the table of contents is the list of tools to use. It's no longer true that I am telling you we're studying fractions, but what we're really studying is one of these tools, and no one ever mentions which tool it really is. Then we're going to go on to mad science. That's my nickname for when we simplify an expression. Expressions are things like these: a bunch of numbers stuck together with arithmetic operations. And we will again revisit those same appearances. It looks like a fraction, it looks like a percent, it looks like a measurement. But now we'll go through all of the tools you use when dealing with an expression. We'll care about what is this situation really like? What methods, what understandings are needed to deal with a situation, instead of focusing on, hey, it's a percent. Of course it's a percent. That's not what's interesting. And then finally, the third Math 20 topic is justice, keeping things balanced, doing the same thing to both sides of an equation. And once again, we deal with fractions and percentages and measurement. But as before, the point isn't that it's about a fraction or a percent or a measurement. The point is that the table of contents has all the tools you're going to use. So it's not your job to somehow figure out what tool this is without it ever being actually named by your instructor. It will be very clear. If you are a Math 25 student, things look more traditional. The Math 25 topics deal with health decisions and personal finance decisions and business decisions. These are also, however, sorted in a nice way. The health decisions that we study are not only the ones that apply most in real life and your degrees and programs and majors care about the most, but they all involve straightforward formulas. You plug things in and get answers out. This is a nice, relaxed way to start Math 25 because you already have plugged things into formulas. You know this game. The personal finance decisions have context-sensitive formulas, meaning that sometimes there's simple interest and sometimes there's compound interest, and some real-life situations behave similar to those but aren't actually either of them. And you have to know which formulas to use, which formulas actually apply to this real-life situation, how much they don't apply, you're just faking it, and to what amount that will make your answer trustworthy or still reliable for making a decision. So we're still just using formulas, but how we're using them matters. It is similar to having multiple pliers in your toolbox, and you have to sort of know which plier to take out at the right time, and what they're good for, and if there's some bizarre job that needs a plier you don't own, which plier can fake it, and what that would do. The last Math 25 topic of business decisions moves on. Now we have procedures instead of formulas. It's not quite as simple because you're not just plugging something into a formula and getting out an answer. Again, the amount of new math is very small. Almost all of Math 25 only uses Math 20 skills and algorithms. But with business decisions, we have to make more decisions that involve a process. How do we price things? Which kind of credit card makes sense? How do we evaluate risks and know what types of likelihood we can live with and which decisions would just be too risky for our business? So things get progressively more abstract as we go through Math 25. Again, this works. I've taught this way before. Students liked it much better than just flipping through the appearance-based categories of fractions and percents and ratios and rates and measurements and geometry. So I hope you also enjoy it. I trust it will also work well for you, and we'll start soon.